The mission for this is to improve data ecology. So what would that mean? ZipaByte is it's about 6 months old, self-funded so far. The mission is to maximize customers' return of investment, but also to save the ecology for both the data and the world. We do that by preventing data swarms, by not shipping the irrelevant data to the data centers, and to organizing the data so you don't have to do full scan of your data just for the purpose of answering a known task. And I want to talk about like 4 major features here that really bring the most value. So Cascade Analytics Engine is extremely fast. It provides elasticity in a very innovative way by essentially varying topology of the tasks, and it also organizes data based on multidimensional organization based on space filling Z-curve. That's where the name of the company comes from. And a few more things I'm going to talk down the road. The application use cases on the data warehouses, the Internet of Things, and the mobile applications. Again, how fast is fast? So we recently performed a so-called star schema benchmark with Mellanox. Mellanox provides hardware. And just to explain, everybody talks about being like able to answer questions on billions of data records in less than a second, for example. But how much hardware is used for that? So we took the top results in a comparable TPCH benchmark, and you can see that here, for example, just in pure performance, we're more than 2 times faster. In terms of the number of nodes used for that, we are much more ecology friendly. And if you look at the performance per node or per CPU core, you see it's at least orders of magnitude better than the current leaders of the industry. It's not like comparing with pure
Microsoft.
Pure Hadoop rates, for example, something like that. Okay. And if you look at the power consumption, this green stuff here is our power consumption. This is measured in terms of dissipated power. And then these are the current industry leaders that scale best across the databases. And those are the rest of the pack. More expensive, more power, less ecology friendly. So about this varying topology, if you're in the data center, you probably have something like interconnected. If you're close to the edge, you can be you can work on a different topology. So in what Derek presented at the beginning of the meeting, it's kind of like you are either in the cloud or you're at the edge. We're saying no, these are just 2 different poles. You can not only be somewhere in the middle, but you can elastically switch, between different levels over here. So for example, if we have a typical IoT architecture with sensors, edge devices, gateways, and the data center. Analytics is done in these 3 tiers. We can have some nodes deployed in those. And for one of the tasks we could do, be completely in the data center. For another task, you might be on the edge device, or you might be in a combination of these layers. Especially this is useful